Image quality indicators, or IQIs, are one of the most important concepts in radiographic testing because they tell you whether the radiograph is actually capable of detecting small discontinuities. Older inspectors still commonly call them penetrameters. Same basic idea. An IQI is a small manufactured test device placed on or near the weld during the radiographic exposure. Its job is not to evaluate weld quality directly. Its job is to verify image quality and radiographic sensitivity. Think about it this way. A radiograph can look clean and still be technically useless. Maybe the density is wrong. Maybe the contrast is poor. Maybe the exposure technique was bad enough that small discontinuities disappeared completely into the image. The IQI acts as a built-in quality control check. If the required IQI features are visible, the radiograph has demonstrated a minimum sensitivity level. If they are not visible, the shot may not meet code requirements even if the weld itself looks acceptable. There are two common IQI systems used in industry. The first is the hole-type IQI, which is very common in ASME applications. This is a thin shim with drilled holes of specific sizes. The second is the wire-type IQI, commonly associated with ISO and European systems. Instead of holes, the indicator contains calibrated wires of different diameters. In both systems, the goal is basically the same. We are checking whether small details can actually be resolved on the radiographic image. Placement matters. Whenever possible, the IQI is placed on the source side of the weld, meaning the side facing the radiation source. It is normally positioned adjacent to the weld area being examined. If source side placement is impossible due to geometry or access limitations, some codes allow film side placement, but this must be identified properly. Incorrect placement can invalidate the sensitivity verification because the IQI may not represent the actual weld conditions. For hole-type IQIs, the radiograph must clearly show the designated essential hole. For wire-type IQIs, the required essential wire must be visible. If the required hole or wire cannot be seen, the radiograph may fail acceptance for image quality, regardless of how good the weld appears. This is one reason why experienced RT personnel spend so much time controlling density, contrast, scatter radiation, and exposure technique. Radiographic sensitivity is commonly expressed as a percentage of material thickness. A typical value might be around 2%, although this depends on the governing code and procedure requirements. For example, on 1-inch thick material, a 2% sensitivity level means the technique can theoretically resolve features around 20 thousandths of an inch in size. Better sensitivity generally means better defect detection capability. Some of the most common RT problems involve IQIs: wrong indicator selection, poor placement, excessive scatter radiation, bad density, low contrast, or simply failing to achieve visibility of the required essential hole or wire. A lot of rejected radiographs are actually technique failures, not weld failures. That is an important distinction in real-world inspection work. Final takeaway: IQIs are not decoration and they are not optional code clutter. They are the proof that the radiographic technique had enough sensitivity to reasonably detect discontinuities. If the required IQI details are not visible, there is no objective evidence that the radiograph could have found small defects in the first place. In radiographic testing, image quality matters just as much as the weld itself.